Okay, let's continue the binomial probability distributions. One good thing about expected value is you don't need to make a table. It's even easier. Suppose a couple has 3 children. Find the probability distribution for number of female children and find the expected value of the number of girls they would have. Okay, so if we normally do expected value, if you have 3 children, you could have 0, 1, 2, or 3 girls. What's the probability of each of these happening? We'll just kind of fast forward. 0 girls would be 1/2 times 1/2 times 1/2, which is 1/8. Same with 3 girls. The other two have a 3 choose 1 in front, so they both end up being 3 and 8. Because if we were to write out all the possibilities, it's girl, 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 boy, girl, boy, girl, boy, girl, girl, boy, boy, girl, boy, girl, boy, girl, boy, boy, and 3 boys. So you can see these are the 8 possibilities. Now what is x times the probability of x for all of these? Anything times 0 is 0. 1 times 3/8 is 3/8. 2 times 3/8 is 6/8. 3 times 1/8 is 3/8. Of course, for expected value, we add this. 3 plus 6 plus 3 is 12. So 12 over 8 reduces to 3/2, or 1.5. So if you had 3 children, the expected value of girls is 1.5. And you might, well, yeah, that makes sense because 50-50 chance. So could there have been an easier way to calculate this? Yes. When the experiment meets the criteria for binomial distribution, the equation for expected value is very simple. The expected value of x is n times p. In our case up here, 3 trials, a 50% chance to get a girl. 3 times 0.5 was 1.5. It could have saved us all that time from making the table. Because over the long haul, it should trend towards the probability, the expected value. That's a general principle for probability, is that the more you do a trial, the closer and closer you should get to the actual probability. It's like taking a sample of people. The more people you sample, the closer to the actual percentage of people that have some characteristic, you should observe that as well, as long as you're picking from a diverse group. So let's do one more problem with all the parts. The national student loan default rate for students who graduated in 2013 is 11.3%. If 10 students from that cohort are randomly selected, find the probability of the following events. Exactly 3 students defaulted on their student loans. So here we have n equals 10. Our probability of success, if we consider defaulting on your student loans a success, is 0.113. Means our 1 minus p is 0.887. And it wants to know the probability that x is 3. Would be 10 choose 3 times 0.113 to the third times 0.887 to the 7th, so the number of people who didn't default. And we go into the calculator from here. We have 10 NCR 3 times 0.113 to the third times 0.887 to the 7th to get 0.0748. We'll go 4 decimal places on this problem. About a 7.5% chance that exactly 3 defaulted. Okay, so this one's a little bit worse. At most, 3 students defaulted on their student loans. That's probability of x is less than or equal to 3, which means I need probability that x is equal to 0, 1, 2, and 3. Now the good news is I already did 3. So what do I have to do here? I need 0, 1, and 2. That would be 10 choose 0 times 0.113 to the 0th times 0.887 to the 10th. 10 choose 1, 0.113 to the 1st, 0.887 to the 9th, and 10 choose 2, 0.113 to the 2nd, 0.887 to the 8th. Oof. Lots of calculation. Again, we don't hate having a calculator for this. First one, 0.3015. The second one, 10 choose 1, times 0.113 to the first, times 0.887 to the ninth, is 0.3841. And then 10 choose 2 is times 0.113 to the second, times 0.887 to the eighth, is 0.2202. We bring this one down as well, and I have to add all of these together. 0.0748 plus 0.3015 plus 0.3841 plus 0.2202 is 0.9806. Okay, so almost all of them, most of the time. Now, what are the chances that at least 3 students defaulted on their student loans? So it would be the probability that x is greater than or equal to 3, which it looks like a lot, right? You have to do 3, 4, 5, 6, 7, 8, 9, and 10. But remember, the probability that x is greater than or equal to 3 is equal to 1 minus the probability that x is less than 3. That is, that x is just 0, 1, and 2. That'd be 1 minus the 3 numbers that we calculated on part B. So 1 minus 0.3015 plus 0.3841 plus 0.2202. These 3. It has to be at least 3. That means it can't be 0, 2, or 1. Now, if we take that 0.9806 and subtract the 0.0748 from part A, it's 1 minus 0.9058, which is 0.0942. Always, if they have you do a large half, always do the easier half. I think one of your homework problems has some horrible, like 60 and you're picking 24 and there's no way out. There's always going to be long. But it tells you to use technology. You might be able to find a binomial probability calculator online to do that. Now, lastly, what is the expected number of students who defaulted on their student loans? Again, the expected value for x here is just n times p. So our n is easy. It's just 10 times 0.113, which would be 1.13 students out of 10. Easy enough. And really, that's all the possible things they're going to have you calculate in 9.4. And even though there is a 9.5, which is kind of a special section, it's not on the test or the finals. So this is the last piece of information that will be on your last test and then ultimately be on your final.